All right, this is section 4.2, the unit circle. So let's start off, we're going to build the unit circle. Let's talk about what the unit circle is. The unit circle is a circle with the equation x squared plus y squared equals 1. The center of this circle is at the point 0, 0, so it's centered at the origin. And the radius is 1. That's why it's a unit circle. So that means from 0, 0 to any point on my circle, that distance is always 1. So we let t correspond to any point xy on the circle and a central angle theta, whose radian measure is t. The arc length formula, s equals r theta, if r is 1, tells me that t is the length of the arc also intercepted by this angle. So basically, I have some angle, bloop, theta. The length of this arc is also theta. That's what the unit circle does for us. So we're going to start by building the unit circle. We're going to add degrees, radians, and coordinates for all the points. We're going to start with these 4 points: positive x-axis, positive y-axis, negative x-axis, negative y-axis. Let's start with degrees. Our angles are always going to be in standard position. So origin is the center or the vertex of the angle. Positive x-axis is the initial side. If my terminal side is also the positive x-axis, that means my angle didn't open at all. That is 0 degrees. In radians, that is also 0 radians. If I go straight up, that opened 90 degrees. And 90 degrees is pi over 2 radians. Remember, we can get that by taking degrees over 180 equals radians over pi. We could do the conversion every time if we need to, or we could have remembered that one. All the way across over here, the negative x-axis, that is 180 degrees. In radians, that is pi. The negative y-axis is 270 degrees. And in radians, that is 3 pi over 2. And then this one's not on the unit circle you'll be filling in, but all the way around the circle is 360 degrees, or 2 pi in radians. Now we need to find the coordinates. This first point, remember that the radius is always 1. Remember x comma y, we go over 1, up and down 0, so that coordinate is 1, 0. At 90 degrees, or pi over 2, we go up 1, left and right 0, so that is the point 0, 1. At pi, or 180 degrees, we go left 1, up and down 0, so that's the point negative 1, 0. And at 270, we go down 1, left and right 0, so that is 0, negative 1. Those are our first 4 coordinates on the unit circle. Now we're going to look at these. These are the middle lines on your unit circle. Let's start with the angles. Well, if it's in the middle of 90 degrees, that must be 45 degrees. And if we count by 45s, we go 45, straight up is 90. Another 45 takes me to 135 degrees, and then 180. Another 45 takes me to 225 degrees, and then 270. And another 45 takes me to 315 degrees, and then 360. To convert, we can also remember that this is pi over 2. Half of that would be pi over 4. And we're counting by pi over 4 in radians. Pi over 4, 2 pi over 4, better known as pi over 2. 3 pi over 4. 4 pi over 4, better known as pi. 5 pi over 4. 6 pi over 4, better known as 3 pi over 2. 7 pi over 4. 8 pi over 4, or 2 pi. Now we need to find the coordinates. And to find the coordinates, we need to imagine our angle here. We're going to drop straight down and make a triangle. So let's draw that triangle separately down here. We draw it so that there's a 90-degree angle. What do we know about this triangle? Well, we know this angle is 45 degrees, which means this one must also be 45 degrees. We know that the radius is 1 because it's a unit circle, and if I look back at my circle, the radius is the hypotenuse of this triangle. We also know that in a 45, 45, 90 triangle, it is isosceles. An isosceles triangle, two sides are the same, so we'll call these x and x. We can use Pythagorean theorem now. X squared plus x squared equals 1 squared. So we have 2x squared equals 1. Divide by 2. X squared equals 1/2. Take the square root. We get x equals positive or negative, but we're talking a triangle, so positive. Square root of 1 over square root of 2, which is 1 over the square root of 2. And we don't like square roots in the denominator, so we get x equals square root of 2 over regular 2. So how does that translate back into my circle? If this side is square root of 2 over 2, and this side is square root of 2 over 2, those are the x and y coordinates for this point, because that's the origin, and that's how far over and up we go. So this point right here is square root of 2 over 2, comma, square root of 2 over 2. Over here at 3 pi over 4. Well, we could make the same triangle. The only difference is that my x-coordinate needs to be negative. So it is negative square root of 2 over 2, positive square root of 2 over 2. At 5 pi over 4, the x and y are both negative. So negative square root of 2 over 2, negative square root of 2 over 2. And at 7 pi over 4, the x is positive, the y is negative. So square root of 2 over 2, negative square root of 2 over 2. All right, now we're going to do these last ones all together. And for these, it's kind of hard to tell in the picture exactly what those angles are going to be. So I want to think about my other special right triangles, the 30, 60, 90. So closest to the x-axis, this line right here, and this line right here, those are going to be our 30s. So that's 30 degrees. And then, I'm going to switch colors here, keep it color-coded. The next one here would be 60 degrees. And then we hit 90. And then add 30, so I get 120 degrees. Another 30 takes me to 150. And then 180. And then 210. And then 240. 270. Add 30, I get 300. And then 330. And then I'm at 360 again. Now for radians. Remember, degrees over 180 equals radians over pi. 30 degrees is really 1/6 of pi, so it's pi over 6. And we count by pi over 6s. So that's 1 pi over 6. My 60 degrees is going to be 2 pi over 6, or pi over 3. And then I hit 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. And then 5 pi over 6. 6 pi over 6, or 1 pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6. So my color coding here, notice that my blue lines are pi over 6s. My reds are pi over 3s. They're very closely connected, but just ever so slightly different. Now let's build a triangle. The 30, 60, 90 triangle comes from an equilateral triangle. In an equilateral triangle, all the sides are exactly the same. All the angles are the same, and they're all 60 degrees. But we want a right triangle. We're talking about right triangle trigonometry. So we take one of the vertices and we go straight down. And because of the way this works, if I make a right triangle there, 60 and 30 degrees. Well, I cut this angle in half, which means I cut this side in half. So this is x divided by 2. So now I'm rocking this triangle. I'll draw slightly again. 30 degrees, 60 degrees, x, and x divided by 2. To make our lives a little easier, we could double this, but let's find this missing side. Let's call it a. So I take x divided by 2 squared plus a squared equals x squared. Wait a second. We know something about this triangle. Back up here, if I have my 60-degree angle, the hypotenuse is 1. Instead of x, let's use 1. Which means this is 1/2. Which means we have 1/2 squared plus a squared equals 1 squared. Which means 1/4 plus a squared equals 1. Which means a squared equals 3/4. Square root both sides. A equals the square root of 3 over the square root of 4, which is 2. This side is square root of 3 over 2. We just found the coordinates. For a 60-degree angle, we go over 1/2, up, square root of 3 over 2. So for my 60-degree angle, I went over 1/2, up, square root of 3 over 2. Which means 2 pi over 3, this is why we're color coding them, right? We go over and up the same amounts, except that we go left, so it's negative 1/2, positive square root of 3 over 2. For 4 pi over 3, we go negative, negative, so negative 1/2, negative square root of 3 over 2. For 5 pi over 3, it is positive, negative, so 1/2, and negative square root of 3 over 2. All right, now we got to think about our 30-degree angle, though. Really, essentially, what I have is instead, I have 30 degrees there, 60 degrees here. Still the radius of 1. Well, guess what? It just swaps the two sides. This is square root of 3 over 2 now. This side is now 1/2. All right, we have our coordinates. Square root of 3 over 2, 1/2. Negative square root of 3 over 2, positive 1/2. Negative square root of 3 over 2, negative 1/2. Positive square root of 3 over 2, negative 1/2. And now we have built the entire unit circle. Couple things here. If the angle you want is not on the unit circle, we just find a coterminal angle that is. Remember, to find coterminal angles, just add or subtract 2 pi, or if you're in degrees, 360 degrees, until you find something that is on the unit circle. This is why we talked about coterminal angles. So by this point, you should have this entire unit circle filled out, good to go. We're going to use it in the next video.